So thank you everyone for coming to today's hastily organised tech chat. Michele is going to be telling us about pandas for flexible data analysis.
Okay, so thank you. So yeah, this talk may have a couple of problems that you already know because, but I think I mean on this level everything works. So so this talk is about pandas and different. It's about my journey in my evolution as a kind of data analyst from the end of my master till now. And yeah, basically pandas is the most advanced framework that I've used for data analysis, and so I want to to share my the wisdom that I acquired with so much pain and effort in the last years. So this is the outline. I will just talk about what I was doing before using pandas. Then I will talk a bit about pandas and add some information for those who don't know what pandas is, but also some information for those who know what pandas is, but they haven't experienced all the pain that they have. And I will talk about some application of it, so how the pandas fits in some data analysis workflows that I have been working on. Yeah, then I will talk a bit about some applications of it, and I will have a digression of some interesting facts in statistics, facts and techniques of statistics that I came up with. So Reveal has this feature that you can actually add this slides down if you want to delve into some details, but we don't need to for this, so I'm fine. So basically, well, during my master thesis, I was working with files in this format, just columns of numbers, okay, they were very homogeneous. If there were any problems, because maybe the problem with producing them. Yeah, so I was working with this kind of data files, and it could happen that maybe the program that was producing these files was crashing from time to time, and then a line would not be completed, but then, we would do usually just manual modification, and we were actually fine with it because we had to actually check that the program was running in the correct way. I mean, it was not something that we could just, make it run without looking at all. We had, anyway, a lot of interaction with the program that was running, producing this data. And, well, if I wanted to compute the average and the standard deviation of the first column, the second column, the first column, which in this case would be quite stupid, well, I would use just this very neat oak one-liner, and I will be done. I mean, I think I managed to go through my master thesis with such kind of analysis. The data was uncorrelated; it was really easy to treat, so it was fun for us. Otherwise, usually we were writing our own programs in C or C++. Yeah, which was that's what we were taught to do, and yeah, so. These are some pros. So all the tools you may want to use are basically out of the box with Bash. Maybe GNU is even installed in a normal standard distributions. It was simple and fast to learn from my colleagues, because my colleagues were using the same kind of technology stack. Let's call it this way. It's just a small stack, but yeah. Anyway, it is what it is. And we were using GNU, and a lot of, for example, these data files we were using, the format was really good to use with GNU, and we were doing a lot of interactive work with GNU, just because we wanted to try different things. And GNU is yet, for me, it's still the most convenient way to plot data quickly. It's really, when you open it, you just type plot and you're done. That with any other thing, it's going to take more time, just that. And of course, course, there are some cons. It's not versatile. The analysis cannot be very complex. And it's not versatile again because if the data format changes, you need to change everything again. And so you need to rely on comments in your scripts. At the time, it was using scripts, I have to say. And when I started my PhD, I had a friend, a colleague then, friend now, which was really, really sort of picky, and yeah, he was really insistent that we should learn Python, okay, and use NumPy, okay. Even if Pandas was available back then, but he was really keen on NumPy, on using NumPy. And yeah, so we were just doing the NumPy way, which it was really cool because we didn't actually have to change our data format at all. We could use awk or, so we could adapt. The cool thing about NumPy is that you can have a header in a file that you can read with load.txt. Okay, and this header will be ignored by NumPy, but at least you know what is the content of the file. And it's quite important when you have, you run some simulations and then you leave the data there for 1 year and you don't remember what is this file, but if you look at the header, it tells you what it is. So yeah, it's not, I mean, having a header there doesn't help from the point of view of software, but it helps from the point of view of data analysis. And yeah, so we were just using, load.txt. Always use that one, this function to load data, and yeah, and you could use all the machinery that NumPy gives you. Yeah, so here all tools straight out of the box with PEEP. It's easier to do more complex data analysis, and you have all the functionality that comes with SciPy, for example, if you need to do fits, minimization, etc. NumPy arrays are really easy to understand. The code is quite fast. It's faster than with awk. Yeah, of course, you can interface it with also bash tools, with the pipes, or using make if you want. And yeah, so the cons of this is that, at the time Python was not everywhere. We needed to have our local installation, our folders in the cluster because there was only Python 2 installed. So we were in the process of pushing for Python 3, and our group needed to have our own installation. Simple analysis are more verbose than just using awk and global. And it's still not extremely versatile because if data format changes, so if you add a column to your files, you need to change the code, or you need to you need to adapt to it. There are issues with missing data, which I remember that I had some problems with missing data. If your arrays are not perfect matrices, perfect arrays of 2D, then you can have problems. And of course, it requires a bit more knowledge. So if I need to tell someone, yeah, use this awk one-liner, they may understand what it is. And if they need to learn Python to do, they need to know. In our field, we need to know Bash anyway because we need to interact with the APC system. So Bash was a thing we needed to know. So we would have to add Python on top of that, which is, I think, it's motivated. It's a good thing. But yeah, it's required a bit of work. When I joined here the RSC group in Swansea, I finally learned about Pandas and the data frames. Before this, I had no idea that such thing existed. Yeah, and yeah, there was Pandas which was working with Pandas, and we were all curious. Wow, what is this Pandas? And it actually was looked really cool because you could do interactive analysis with IPython, and yeah, you could do these very clever tricks and do very complex things quickly. Yeah, and I think that the idea of the Pandas data frame is that it's actually stolen from R, but I think the cool thing is that it's Python, so you have actually a bit more. The syntax is not as beautiful as we with R. Because of discussion that we had with, we remember having the discussion with Mike. But yeah, anyway, you have Python and you have much more possibilities with it. You can do SQL-like joins, yeah, like joins within two tables and SQL. You can do this with Pandas as well. not very, I mean, sometimes you need to, I mean, it's not that I need to do it very often, but when I need to, I can, so it's really nice. Basically, a data frame is a list of Pandas series, which are like vectors in R. I'm not sure. Are Pandas series like vectors in R? I mean, I think that they are just atomic data, so they can contain only one kind of data. So they can basically, they are basically NumPy arrays in the sense, the Pandas series. So when you have a data frame, you have a bunch of them, they can be different types. You can use smart indexing, so if you want to access the data there, you can use different operations that, you know, which are a superset of what you can do with NumPy. And it works well with Python, as we said. And well, if someone needs a refresher or wants to start using Pandas, there's this 10 minutes to Pandas tutorial, which is a gold mine. I think it's not 10 minutes because, but yeah, we went through this and it was much more than 10 minutes, but it was worth it. So yeah, it teaches you a lot of things quick. Yeah. So it just, I mean, what would we do if we wanted to do the same things with that we did before with using Pandas data frames? Well, we'd have to change our files a little. We would have to add a header here. Okay, so the first line needs to contain the name of the columns. The thing that people teach about Pandas in the first place is like to use this read CSV function. I hate it. It's something that I did for a long time. You can change it, saying that instead of having the comma as a separator, you want something else, but it doesn't work so nicely. And then I actually found out that read CSV is a wrapper around this read table function, where you can actually specify any separator you want in a regular expression, and you're fine. And this little, you know, let's say, yes, this expression here works really well, and it helps you. Because, I mean, if you use this, you can actually have human readable files. And treat them with this. Otherwise, you know, if the comma separated value files, it's a bit harder to understand what they do or what is the content. Yeah, so I recommend using it instead of read CSV. Or if you want to use read CSV, you can, but it's the same as just using a comma as a separator here. So yeah. So okay. Yeah, there are this kind of function that help you putting data in reading data into Python. Yeah, if you want to output, you can use the toCSV file, which is the toCSV function, which actually is quite nice. You can also use instead of a comma separator, a tab, which I like because it makes it a bit more readable. Actually, there's a nicer option if you really want to read the tables, if you wanted to interact with them as a human. You can actually use this module, which is called tabulate, okay? And it gives you something that looks like what we can see on the bottom of the screen here. And yeah, I mean, it's not really nice if you need to pass this kind of format somewhere to any. But yeah, you can anyway print it in different ways. You know, just you can print this version to interact with it if you need to look at, to visualize it in some way. And you can print another version which is more machine friendly at the same time. So yeah. So one cool thing about Pandas is that you can access the data in data frames in more sophisticated ways than NumPy. When I started using Pandas last year, I found it a bit, actually it was early this year, I found it a bit sort of, it was not really immediate, because I was used to just use integers to access data, like accessing the elements of an array, it's done with integers. But yeah, in Pandas you can do clever things. like basically using the data frame itself as a sort of a dictionary, okay? Thanks to the indexing feature. Okay? It's actually very good because from a sort of consistency way of, I mean, for the consistencies of your analysis. Because if you need to convert everything to integers and then back, it's yeah. So the cool thing is that you can take a data frame which is called df here, and you can actually make an index out of one of its columns. Okay. So then you will be able to access its data by looking at the values in that column. There are workarounds. If you want, you can actually say, you know, you can do this even with NumPy arrays, but you need to use some workarounds, which I'm quite happy. Is that I think that this is one of the selling point of Pandas. And yeah, it's cool if you do so to actually reorder the data frame so that the indexing is faster, because of course if you know, accessing a sorted data structure is much faster than an unsorted data structure, unless you use hash. But yeah, anyway, what you can also do is specify a bunch of columns as the index. Okay, but in this way you are going to obtain a multi-index. Okay, which can be used to either simulate multi-dimensional data, okay? Because then you will have like more indices to choose, or it can be seen as sort of a hierarchical kind of data structure. It's cool because it can be sliced on different levels, so you can actually think if you have, like in this case, you have three columns that became part of the index, and you can see this as a sort of a cube, okay, because it has 3 dimensions, three indices, and you can slice it along different directions. The only thing you need to be careful about is that when you do this, the columns that you have chosen as index basically disappear from the data frame. And so if you want to do some things like a group by, or well, they don't work. But you can always recover the original data frame, set up the original data frame layout with this reset index function. Yeah, so yeah, data can be still accessed in the NumPy way. So for example, with array of booleans, okay, but also in this dict way. So just specifying the label we want with the lock function, okay, and yeah, you can do different. You can access in different ways. There are some caveats. You can use tuples to access data in the data frame which has a multi-index. Okay. You can use also list of tuples or tuple lists and or slices. So here's an example. For example, first example, you have 2 labels in the rows. Okay, so this is going to give you a data frame. Okay, the result of this expression is the data frame, okay, which has 2 rows and as many columns as the original data frame had. So second example, you should get a series or like a tuple of because you have just 1 row and as many columns as you had in the original data frame. I think, I mean, if the data frame is homogeneous in all his the types, I think this gives you just a series. If not, I think it gives you something like a tuple or I don't remember. Sorry. Yeah, so the third line, well, let's give you a series because that's exactly what the frame is. You're just selecting one of the series that are in the data frame. So in the fourth example is something that you would use when you have a multi-index in the rows. Okay, so you basically would select just 1 row. Okay, in this data frame. The fifth example is the same, but when the multi-index is on the columns. Can help also when the column says multi-index. Okay. Then the sixth example is when you get just a single value. Usually, doesn't have to be. because maybe there are more values that match that index value. So, for example, if you have, if you need an example, I can give you. The last example is just to show you. You can actually get an equivalent times one data frame if instead of passing just values, you just pass lists of one element. Yeah. And these kind of considerations are useful when you actually put these expressions in your script, because sometimes you in your programs, because if you don't think about this, you don't know what type you're going to get, and so if you put the second last expression instead of the last one, you will get a value which will have different, which will just have different methods, and your code is going to blow up. So yeah, I think that I like most the last expression, last kind of expression, because that's the one that gives you the. Of course, it depends on the use case. But if you can try to always stick, in my opinion, to the last expression, so you always work with data frames, and then when you want to extract something that you know exactly what it is, you may use the second last, or depending. Anyway, let's move on. If there are any questions, stop me.
What's data frame?
What's well, it's I can try to give this a very. So it's a representation in memory of a file of which is. Do you accept this as a definition? It's a representation in memory of a table of data. Yeah. Okay, so this is enough with the explaining what the data frame is. I just want to talk about what I've been doing with that, with data frames. So here is a workflow which is quite feasible. I'm pleasantly surprised. This is a project I was working on. I'm still working on it. Where basically we get some data from HPC, okay, that is being produced by a program which is being optimized by our group, by SHC, and we need to do some analysis on this. And here is a workflow on how things should work. And the point that I want to stress here is that there are like 4 kind of data sources, which are the balls on in the highest row, okay, and they tend to have a slightly different data format, okay. For example, the old ones, old Simon, for example, had a different number of columns, and also there are some things I don't even remember anymore what the data format is, if we're exactly. I know that there is a difference, but the reason I don't know is because I'm using Pandas data frames. So I just need to remember at a certain point that I need to strap a header on. You see here, for example, in one of these data files as a column more than the other, and so the solution is that if I use read table in my scripts, I can just strap a different header on each file and be sure that my script will not need to be changed. So that's why I don't remember exactly what was the format for each of these, because because I just solved this problem once for all, and I'm happy. Second example. Second example has been a bit more. In the second example, the usage of Pandas and the data frames and all the features that they provide and the functionalities has been much more interesting, much more important than the first. The first kind of, just to say, so this kind of data flow or this kind of analysis is something that I've been doing during my master thesis in my PhD a lot of times, and we were fine with using NumPy arrays, and but of course, it's better now, because I remember when I had some changes in the data format. then it was it was somehow painful, but yeah, here it's much easier by using Pandas data frames. The code became easier. Yeah. So in this case, instead, and for this second example, we have some data that comes from a guy from economics, and it was not a particularly large data set by today's standards. It's not big data, but it was anyway, 100, etc. Almost 2,000, all the 2,000 rows times 700 columns, and we wanted to do some analysis on it to see, for example, if there was some repeated data, if there was some data which was not independent from each other. I mean, we wanted to understand this amount of data. And it came to us in a form of in an Excel file. Okay? Well, Excel, they say it's bad for science, so well, just let's change and start using something that I know. So use Python and some other tools. At the time, we didn't know if we wanted to use Pandas or something more, something fancier. There were different data structures we could use. For example, there's X-array, which gives you some like Panda data frames, but with more dimensions. But anyway, we know that by using multi-indices, we can just replicate the kind of functionality in Pandas. Anyway, so eventually, I didn't use X-array. In some production environment, enterprise, they use all-up cubes, things like this. I was trying to explore these things, but everything was quite, I was not too easy and looked a bit abstract, so I decided to just stick to Pandas because that's what it seems much more reachable. And so, so that was the data, how it came to us. It was a data representing, basically we had some measurements of different social indicators like employment, GVA, employments in different sectors for many regions in Europe. Yeah? So first one, for example, the first ones that we see here are just regions in Austria, and the last ones are regions in the UK. And it's a sort of, it's worth noting that actually these regions are organized in a hierarchical way. So there's data at the national level. For example, you have this 80. 80 stands for Austria, so it's the whole, the things that are on this row, okay, the first row, regard the whole, Austria as a whole, okay. Then you have 81, which is a sub-region of Austria, okay, which has some sub-regions. For example, there's 81.1, it's another sub-region in a sub-region of Austria, and so on. And you have basically 3 levels. So 4 levels in a sense. You have the national level, the NUTS 1 level, the NUTS 2, and the NUTS 3. Okay? And NUTS 3 regions are contained in the NUTS 2 region, NUTS 2 regions are contained in the NUTS 1 region, and NUTS 1 regions are contained in the nation. Okay? And so, well, it's pretty clearly a sort of hierarchical data set. Okay? So why not use the Pandas multi-index with its hierarchical thing to hierarchical mood or whatever. I decided to clean the data, and in order to do that, I went through this data frame. This is a data flow. So I took the. Let's see if this zooming works. Okay. Yeah. So I started from the Excel file. Then I converted it to CSV using LibreOffice because that's the only thing I thought I could use. Okay. Then I got a data frame, but it had very strange column names. Okay. I think it was a bug in LibreOffice. Okay. Then basically I decided that I could remove a lot of data, which was basically duplicated data, in the sense that data that could be reobtained by from other data in the data frame. Like for example, there was employment in agriculture, given in units of people. Okay, but there was also another column which was the proportional employment in agriculture, which was just the ratio between the absolute employment in agriculture divided by total employment, things like this. So there were a lot of data. There were a lot of data that could just be, obtained by other pieces of data in the data frame. So, and after this, well, what we did, okay, we had to actually correct the column names and plug them in again in the right in the data frame with the right column names. Then there were some problems with some notation in this NUTS region, in the names of NUTS region. So there's a region in Germany which had just changed the names along the, and yeah, so it was crazy. And yeah, so I managed to actually get to remove all the data which was not pertaining to NUTS 3, so to the smallest region, because of course the data for larger regions can always be obtained summing the data for smaller ones. And after that, I wanted to be sure that what I did was correct, so I did some consistency checks. And yeah, so after this, I wanted to just go with the change basically the structure of the data frame itself. Instead of having a lot of columns and a lot of rows, I would have just a few columns representing, I don't know, employment, GVA, and then a lot of rows representing years and the date and the region. Okay, and then I would do some visualizations, checks, etc. What I wanted to point your attention at here is that there's a lot of red stuff here, which represent what I should have done, what I would have done if I had more experience. Okay, that's to say, yeah, there's going to be a discussion at the end, the conclusion that, I mean, there's but when you do something, when you learn a new thing, you want also to use it, and there's this problem with exploitation versus exploration. So here I was in a phase which I was exploring a bit and using the tools that I discovered to do the job. But if I explored a bit more, I would have found something better. And yeah, but yeah, I guess that our job is full of this kind of trade-offs. Anyway, after all, I got this representation of data in terms of a data frame which had a hierarchical index. So yeah, we have just only 9 columns, which are, as I saw, GA, employment in different sectors, etc. With a lot of rows, and the rows are representing, basically the rows are a tensor product of the regions, only level 3 regions, because level 2 and 1 can be computed, and the year. Okay, I could have done something different. For example, I could have kept the year on the other axis. Okay, but I didn't think about that because of my inexperience. So yeah, that's what I mean by here. If I could have used this data structure with multi-index on both columns and rows, and instead I decided to use just this structure here with a multi-index on rows. Okay, so thing is, I wanted to visualize this. I mean, even if I managed to clean the data quite a lot, yeah, it's. Even if I managed to clean the data quite a lot and reorganize it in a more sensible way, we wanted still to be able to see what the data was. I mean, what were the information in the data? Of course, we could just compute some quantities and like correlations between regions, or but yeah. But I think that since it was data that was related to some kind of geographical object, underlying geographical object, well, the thing is, the best thing to show the data is use a so-called choropleth map. Basically, a map which, I'll show you what I mean. So for this, I needed to get some data regarding the shape of regions, okay? And the shape of regions is usually presented in GeoJSON format, okay? I downloaded this data from this website, which is linked here, and then I had a couple of options. So how do I plot this data? So if you Google it, Google ways to plot geographical data, you find, the first things that run on Google are, there's some highly advertised tools that I'm not going to talk about because I hate them. Yes, and they have premium versions and work only online because you need just to, to plug your, it works on your Jupyter notebook. You just put a link to, I don't know, you use the library, which basically links automatically with the website. And so I didn't want to do that. So I went for option 2, which is just parse the JSON, which is easy in Python because you have libraries to do this. And you get the geometry information and use matplotlib, which is the thing that I've used forever, basically. And yes, you use matplotlib to plot everything. It's slow and unwieldy. And I've written 139 lines of code for this, which is a waste. Because, after writing this code, I found out that there was another, that I found that basically it sucks, and there's another nicer way, which is using GeoPandas, which I found after a lucky search on Google after, just 2 weeks that I was doing this on and off, and I thought, oh, there should be a better way to do this. And so with GeoPandas, you can just read the GeoJSON file without actually delving into the JSON format at all. Okay? It gives you a geodata frame, and then you can use the geodata frame to join the normal data frame with a function which is GDF, geodata frame merge, which is like join in between two data frames, but for some reason I don't know why. Joining with data frames from Pandas doesn't work, but if you use merge, it worked. So, well, happy. And here is what a color-breath map is. If you are colorblind, I'm sorry. I don't know. You are colorblind. Yeah. Do you see something? Sorry, I don't know.
No, it's fine.
We had the discussion. There are some sets of colors that can be used for colorblind people. I didn't care.
No, it's fine.
Oh, no, I had to, because actually Don is colorblind as well, so I think this should be colorblind friendly. Anyway, so basically what I did is I produced a color-breath map of the variation of quantity that we were interested in for each year, okay? And so I got a lot of images and stacked them with FMPEG, and I got this nice quote unquote GIF, and so that's it. And I think, well, this data in this form is much more readable than the table. Yeah, I think sorry for stating the obvious.
Just one comment.
The
color we usually use, like ranges, it's usually the opposite way, right? We use that the bright ones.
The bright ones here represent increase.
Yeah.
I think this is employment, right? So this is an increase in employment. So when it's yellow, it means that the employment that year grew a lot, and when it's cold, when it's violet, then the
numbers changing on the legend.
Yeah. So here is +10, and here is -10.
So the range is fixed, right?
The range is fixed.
Okay.
Yeah. Okay, so in interest of time. So there's another thing I wanted to say. So after visualizing this, there's another thing we wanted to look at, which was how interdependent are the different regions. Okay, because we want to see how much data do we have in this data set. If we have two regions which are just very interconnected, their behavior, the way that the behavior in time is going to be very similar, okay? And this is not going to give us any information. If we cannot consider these two regions as independent. So I wanted to study this, and then we found something interesting in the data, in a sense. So just a little small mathematical regression is this. So if you have any independent variables with an equal distribution, okay, then the sum of those variables, okay, take the sum of the variables, and then take the standard deviation of it, and it's going to go as the square root of n, okay, where n is the number of variables you have, okay, times the standard deviation of a single variable. If those variables are really correlated, like rho equal 1, like they just are the same variable, okay, then this behaves in a different way. So it's not the square root, okay, it doesn't go as the square root of n, but this goes like n, okay. It's easy to prove. I think it's just a, yeah. So assuming that each xy of these variables is the fluctuation of employment, let's say, in a small subregion of a fixed size, we don't exactly know that, it's not important here, then each region, we can consider that each region is subdivided in n subregions, where n is actually proportional to the size of the region, which in this case means the total employment in the region. Yeah. So by looking at the relationship between the size of the regions and the fluctuations, okay, we can find out if it's of square root of n, so total independent, okay, different worlds, or if it's like n, so it means that all the regions go together. Okay. And where is it? Okay. This is the result. Okay. Now this is logarithmic, so you know any power law in bilogarithmic scale is a line. Okay. But here, if you go to site, you can see that, well, the power law fit is with there's a coefficient, which we don't care about, and x to the 0.8. It's closer to 1 than to 0.5. Yeah, I was more convinced that it was close to 1. Because looking at the data, it looked more like. So this means that possibly our data set is really correlated, and maybe, I mean, we don't need to use this. I mean, we don't have so much information in the data set as we thought. Yeah. So that was one result. And one thing I want to do on this data set is to do some causality analysis. Just to say, we wanted to explore this problem, which is that, which is the following. If we look at GVA variation, GVA stands for gross value added. Sorry for not stating it before. Okay, so it's basically the increase of GDP, gross product, domestic product. But GVA is a bit different concept. So if GVA varies and employment varies, so is there a sort of causality relationship between these two? So is the GVA increase that drives the growth in GVA that propels increase in employment? I mean, basically, increase in GVA creates more jobs. Or instead, is the creation of more jobs that drives growth? Okay, and people of different schools, economists of different schools, have different opinions, and there's no conclusive evidence towards any of these. Okay, but what does our data say about it? Of course, we won't be able to just, you know, we can chime in the debate. We are not going to be able to say anything conclusive, because usually people who do this kind of studies, they do it with very complicated models, taking into account a lot of different things. We have just, you know, employment and GVA, we can say, well. And in order to do this kind of analysis, okay, there's a concept which is called the Granger causality. Okay, and it's enunciated like this. So say you have two time series. In this case, it's like the GVA data and the employment data. If you have two of these, you can say that X, okay, so let's say employment, does not cause the series Y, GVA, okay? If this is true, I mean, what does it mean? So, basically, Y at t plus 1, GVA at t plus 1 is independent of this in the information available in the universe at time t, okay, given the information given in the universe given at time t minus the information in x. Okay. You need a bit more time. I need a bit of time to understand this. But the idea is, so if I have y, and I want to say check if y is caused by x, okay, then I can do this. So I can say y is only caused by itself. So I created this autoregressive model, and I say, well, there are these a coefficients, and y at time t depends only on itself. And of course, this is not going to be true. Okay, there's going to always be some error. Okay, and then I do another hypothesis, which is, just assume that y depends also on x. Okay, with some other kind of another bunch of coefficients. Okay, and I will get some other epsilon, some other errors. Okay, these errors, epsilon prime is going to be smaller, but basically what it's, yeah, you can prove it. Okay, so if x doesn't cause y, okay, the two variables, the sum of epsilon squared and the sum of epsilon prime squared, should be equal. Okay. Of course, we are doing statistics, everything, the fluctuation, etc., etc. You don't have to say that these things are equal or not equal. That's actually what we want to say. Okay? We need to use some kind of test, and this is actually called in statistics an F-test because just a definition. Okay? Yeah. So, well, that's what we want to do eventually. Okay? I haven't managed to do that, but that's the point. So, conclusions. Actually, these are meta-conclusions because I think the conclusion I have drawn them already in the thing during the talk. So, learning is a process which is in competition with productivity to some extent. This is the famous exploitation versus exploration trade-off. Okay? Finding the right tools to do something requires a non-negligible time investment, and so it's that's it. Gone already through this. And data analysis faces similar challenges to software development, in the sense that software development needs to cope with change, and also data analysis needs to. And that's over. So thank you for your attention.
Thank you very much. We have time for